Okay, welcome back. Now we're going to be factoring using something we used before called a perfect square. If you remember, we did a plus b squared was equal to, our end result was a squared plus 2ab plus b squared. Now, if we find out that we've got something, a perfect expanded form of a perfect squared, we can go back to this as our factored form. And that's our goal here when we are looking for factoring this, okay? So let's get rid of the stuff from last video, definitely. We'll get rid of that. And let's get started on some questions. Right, so we're going to leave that where it is, and we'll use it as a guide. So remember that our end result has to kind of follow that formula. So we've got x squared plus 6x plus 9. So if we say that a is x, so we've got a squared plus 2 times a times b plus b squared. Okay, so we know in this one that a is going to be equal to x. So we can say that we've got that one result. Okay, you know a is equal to x. We've got 2 times our x, 2 times x, and then times b squared will be 3. So 2 times x times 3, and then we've got 3 squared. And that's equivalent to this, which means we have a perfect square. So when we have a perfect square, we know that this will actually be equal to x plus 3 squared, and it's very kind of easy to do. It's easy to find this part and this term as being both numbers that are squared. The thing we just have to check is that this is 2 times the square root of 1, which is x, times the square root of 1, the other, which is 3. That's our real test, and the only difficulty in these questions is checking to see if that is true. And an easy way to do that is just to divide by both and to see what's left. If we know that x is there and that's going to be our a, we can easily get rid of it and only consider the number 6. Is 6 going to be 2 times the square root of this? And that's our big test. Okay, so let's get rid of that and move on to another one. X squared minus 12x plus 36. Okay, clearly 36 is 6 squared, and x squared is x squared. So if we consider x to be a, then we only need to think of this particular value here. So if we divide this by 2, we should get x squared minus plus 2 times negative 6 times our x is equal to plus 36. Okay, if that's true, if this here is true, if we divide it by positive 2 and we divide it by x and we end up with something that when it's squared is equal to 36 and minus 6 squared does equal 36, then we have our answer. And it also tells us when we have it in this form here where we have a negative out the front, that we've got a perfect square with a negative in it. So this will be equal to x minus 6 squared. So whenever we have x plus 6 or something squared, it will always be equal to x plus 12x plus 36. And every single individual operation will be positive. But whenever we have a perfect square where there's a negative in the middle, this second term here will always be a negative. Alright, let's get on to another one. We have 4x squared plus 12x plus 9. Okay. Is this term something squared? Yes, it's 2x squared. If I square the 2, I get 4. If I square the x, I get x squared. Is this second, third term something squared? Yes, it's 3 squared. If I divide this middle term by 2, I divide it by 2x rather, which is dividing it by a. Yeah. Then I'll get rid of the x, get rid of this, and I'm left with 6. Is 6 2 times our third term? Yes, it is. So this is a perfect square. And we're left with 2x plus 3 squared. Will give you this exact answer. Now, all of these little tests that I'm coming up with are just relationships between these numbers to make this work. You can use whatever tests you would like. You just need to think about it logically. Right. 9a squared minus 24a plus 16. Okay, first up, is the first term something squared? Yes, it's 3a squared. Is the last term something squared? Yes, it's 4 squared. If I were to divide this by 2, would I be left with a times c? Yes, I would, because if I divide this by 2, I'm left with minus 12a, and 3a times 4 is going to be it's not going to be 12a, because we have to change one value, and that is change this to a negative 4. So this is still a perfect square, but because the second term is negative, it's going to be 3n minus 4 squared. Alright, now we have 4x squared minus 20. It's a bit of a weird 20. That minus 20x plus 25. Alright, again, is this something squared? Yes, it's 2x squared. Is this something squared? Yes, it's 5 squared. Because this is negative, that means it's going to be equal to something minus something squared. Okay, so we've sorted all these common things out. Does this equal 2 times our first term multiplied by a negative of our second term? Does that equal minus 20x? Well, this is going to be 4x times negative 5, which is negative 20x. So it does, in fact, all equal out, and we can rewrite this as 2x minus 5 squared, and we are done. So in order to solve these, you do need kind of a complicated, or not complicated, but at least a reasonable understanding of the basic formula of a perfect square, and also just how to manipulate it and think about it. Once you get down, it's really useful to be able to do this and really easily notice that you have a perfect square that is easily factored. Okay, that's it for this video. Hopefully it's helpful, and I will see you in the next one.